Hi, in this video, I'm looking at solving algebraic permutation problems. And so what I mean by this is problems where the n or the r, usually the n has some sort of algebraic expression in it, and we want to solve for an unknown with that. So if I look at my first problem, I've got n plus 1 p4 equals 2 times n plus 2 p4. So what this means is the fact that my n plus 1 p4 here and my n plus 2 p4, when I go to substitute it into the npr formula, where I've got n factorial on n minus r all factorialed, instead of writing just n, wherever I've got n, I'm going to replace it with n plus 1 or n plus 2 and then solve from there. So if we look at how we do that, on the left-hand side, I've got n plus 1 p4, and so I'm going to have something factorial, and that something, because it was n, is going to be n plus 1 factorial. So I'll replace the n with the entirety of, this is basically n here in the formula. So then if I keep going, the next step is to do n minus r factorial. Well, that means I'm going to need a lot because I'm going to be having a fair bit underneath here. So I'll extend out my vinculum. And my r is 4, so I'll put in the minus 4. So that was my r value. But I've got to put my n value in there again. And my n value is this complete n plus 1. So I just replace wherever n is with whatever I've got in place of n in the formula. Let's do this to the second side. So I've got 2 times whatever this is. So on top, we've got n plus 2 So on top, we've got n factorial, but n at this point is n plus 2. So I'm going to have n plus 2 factorial. On the bottom, we're going to have a big factorial. My r is 4, so I'm going to have minus 4. And where n was, I'm going to have n plus 2, because I had that n on the bottom there. So I've got n plus 2 minus 4. Now all I've got to do is treat this as an algebraic factorial problem. But let's start off with simplifying this bottom bit first. So on top here, I've got n plus 1 factorial. I'm just going to leave that alone for now. On the bottom, I've got n plus 1 take away 4. Now, even though I've got that n plus 1 in brackets and then follow that by a take away 4, because there's nothing multiplying these brackets other than a times 1, I can just ignore them. So it's basically the same as having n plus 1 take away 4 written there, which is n take away 3. So I've got n plus 1 factorial on n take 3 factorial. And that's going to equal to 2 times. And then on top, I've got n plus 2 factorial. I'm just going to leave that alone. But then on the bottom, I've got n plus 2 take away 4. So plus 2 take away 4 is going to be minus 2. So I've got n take 2 factorial. Keep working this out. Let's expand out these 4 factorials. So on top of my left, I've got n plus 1. And the next number down is n. And then n minus 1. And then n minus 2. And then n minus 3. And then n minus 4. And that just keeps going forever until we reach 1, which we don't really know where it is. And on the bottom, we've got n minus 3 times n minus 4. And again, that's just going to keep going. And we've got enough here to show that the minus 3, the minus 3, and the minus 4, and the minus 4, and everything else is going to cancel out, leaving us with this part of the expression here. So we'll just write that below while we've got it. So here we've got left n plus 1 times n minus 1 times n minus 2. Let's have a look at the right-hand side now, doing the same thing. I've still got that 2 times there. We're just going to leave that there. On top, we've got n plus 2. The next number down is n plus 1, then n minus 1, then n minus 2, then n minus 3, and that pattern just keeps going. On the bottom, we're starting with n minus 2, and the next number down will be n minus 3, and n minus 4, and so on. And that's enough to show us that the n minus 2's will cancel, the n minus 3's will cancel, and everything else will cancel. And so we're going to be left with 2 outside of n plus 2 times n plus 1 times n minus 1 on the right-hand side. So now I've just got to simplify this expression down to find n. Now, to do this is going to be a bit easier if we start cancelling things out, because I've got products only on the left and right, so I can see what's going to cancel. I can see that both sides have an n, so I can divide both sides by n to cancel out the n's. I can see that both sides have an n minus 1, so I can cancel out those by dividing by n minus 1. Both sides also have an n plus 1, so I can divide both sides to cancel them out. So I'm cancelling out the n with the n minus 1 with the n minus 1, and the n plus 1 with the n plus 1. And that's leaving us with n minus 2 on the left being multiplied by nothing else, equaling 2 times n plus 2 on the right. And so if we then expand this bracket that I've got on the right, we've got 2n plus 4. And then what we will do, we can subtract an n from both sides, and we'll subtract a 4 from both sides. And then that's going to give us a negative 6 on the left and an n on the right. So for this one, n equals negative 6 will make it work for n plus 1 p4 equals 2 times n plus 2 p4. But the problem with this solution is if I look at what I've got, if n is negative 6, negative 6 plus 1 is negative 5. And negative 6 plus 2 is negative 4. But we can't actually have a negative n value into our formula because factorials are not defined with negative numbers. So even though we've found an algebraic solution to this problem, it's not a valid solution because when we go and put it back into the original equation, we get negative numbers. So the last thing I'm going to say with this is that it's not a valid solution, as n must be greater than 0. It must be a positive number. And even though here we got negative 6, if up the top here in our original formula we had like plus 7 and plus 8, then it would have been fine. But because I've ended up with not enough to get me into positive numbers, this is not a valid solution. So let's go and have a look at my second problem. My second problem is I've got 7 times np3 equals 6 times n plus 1 p3. So in this case, we've only got one n plus 1 to deal with, but we still need to work our way through, see if there's any tricky things in here. So on my left-hand side, I've got 7 times np3, which is just going to be n factorial on n minus 3 factorial. Nice and easy. On the right, I've got 6 times n plus 1 factorial on n plus 1 minus 3 all factorialed. So let's tidy up this right-hand side. So we'll just leave the left as is. And on this right-hand side, we've got n plus 1 factorial on top and n minus 2 factorial on the bottom. So now let's write these out as factorial problems. So I've got 7 times n times n minus 1 times n minus 2, and everything from n minus 3 onwards will cancel, so I'm just going to leave it as that, equals 6 times, well, we've got n plus 1, n minus 1, and everything from n minus 2 will be cancelled out by the denominator. So now we can look at what we can cancel, and I can divide both sides by n to cancel out my n's. I can also divide both sides by n minus 1 to cancel out my n minus 1's. And that leaves us with 7 outside of n minus 2 equals 6 outside of n plus 1. So we have 7n minus 14 equals 6n plus 6. And so then if we minus 6n from both sides and add 14 to both sides, we'll be able to see that our final result is that n will equal 20. Do a quick check with our original question just to make sure this works. 20 works with a positive number. 20 plus 1 is 21, still a positive number. So this will work as a valid solution. So 20 is our answer to this one. So there we go. If we have algebraic permutation problems where either our n, usually our n, or perhaps our r has algebraic expressions in them, we just got to substitute into an NPR formula, being careful to how we're placing it in. Remember to place everything in the correct placeholder. Sort out any additions and subtractions, and then treat it as a factorial problem. Cancel out what needs to be cancelled out, and solve the equation that you result with at the end. Only thing we got to remember is that the n in the actual NPR formula, in this formula, n must be positive. It must be greater than 1. So if when we get to an answer and we go and put it into our original question and it wasn't a positive number, then the answer is not valid to begin with.